Okay, so question number 6 says, what is the height of a ball 2 seconds after it is dropped from a building 100 feet high? We have a generic equation for any time an object is in motion. That is y equals negative 16 t squared plus v sub 0 t plus h sub 0. Now, let's just talk about that. That's a parabola, and the different letters stand for, this is the height at any moment. T is the time, its number of seconds. H with a little 0 after it is the initial height. And v with a little 0 is the initial velocity or speed. Okay, so now what we want to do is we want to figure out what information do we have in our equation. The negative 16 is a constant. That's, as long as we're measuring in feet, that's going to be a negative 16. 2 seconds. And let's see, initial velocity. When you drop something, your initial velocity is 0. You're not putting any speed on that object. We're not throwing it. We're not striking it with a golf club or anything like that. So that's just going to be a 0. I'm not even going to put in a value for this particular term at all. Plus the initial height. And the initial height was given to me as a 100. So let's do some calculations here. We've got negative 16 times 4 plus 100. And that's going to be negative 64 plus 100, which gives me a final answer of 36 feet. Question number 7. Question number 7 says, please rewrite this equation in vertex form. And our hint is to use the completing the square strategy. We've used that already in our final review, but we can do it again. Our strategy is we take, our first two, our a squared and our bx, our ax squared and our bx term, and we space them out a little bit. What we're looking for is a value that we can put inside these parentheses so that that's a perfect square. And what we do when the a value is 1 is we just take half of this term and double it. So that's going to be a plus 16. Balance it with a negative 16 out here. And we'll do a quick rewrite. We've got y equals x plus 4 squared. You'll notice the 4 was the square root of 16. It's also half of this 8 value. If you foiled these, if you wrote these as two separate terms and foiled them, you would get this same answer, x squared plus 8x plus 16. Outside, I got a negative 23, or minus 23. And as we talked before, our vertex form is the opposite of this term, right? This is x minus h. So that means my h value is going to be a negative 4. And then minus the k value. The k value is just 23. If you remember how those vertical and horizontal translations work, it's the opposite of what's happening to the x, and it is what's happening to the entire function. So this means our vertex is at x value of negative 4, a y value of positive 23. Question number 8. It says I to the 9th is equivalent to what? I is the square root of negative 1. We talked about complex numbers in this class. So if I squared is equal to negative 1. Let's use that for a moment here. I to the 9th, therefore, is kind of like, if this is 9 i's all multiplied by each other, if we did the most work possible for this question, the most work possible, meaning no shortcuts, that would be this. A whole bunch of i's multiplied by each other. And then we pair them up. Now, every time we have 2 of these guys, 2 of these i's, that's equal to negative 1 because I squared is equal to negative 1. I is the square root of negative 1. So that means that this is negative 1 times negative 1 times negative 1 times negative 1 times I. Well, what's negative 1 times negative 1? Negative 1 times negative 1 is 1. And negative 1 times negative 1 is 1. I got 1 times I, which is just equal to I. Now, that would be the long way to do it. The other thing you can do, of course, is you can recognize that there is a pattern. Any even power of I, right? Any even power of I is going to be either 1 or negative 1. Matter of fact, the I values only have 4 different things. I to the 0 is equal to 1. Anything to the 0 power is 1. I to the first is I. I squared is negative 1. I cubed would be negative 1 times I, which is negative I. And then they repeat. So these 4 are the only different values for all of the powers of I. So you could just figure, you could just count by 4s. So I to the 9th is going to be the same as I to the first, because it would be I to the first, right? The 1, and then 4 i's, right? I to the 4th. I to the 9th would be I to the first times I to the 4th times I to the 4th, and I to the 4th is 1. So, okay, question number 9. Question number 9 is also dealing with imaginary numbers. It's subtraction. Now, you can punch this one in on your calculator. Your calculator, if it's in complex mode, A plus BI, that's complex mode on your mode button. You can do this on your calculator. It's not too difficult to do without. We just stack the terms. Put your real number over the real number and the imaginary numbers on top of each other. And in this case, we've got negative 1 minus 8. So negative 1 minus 8 is negative 9. I minus 9i is minus 8i, and we're done. So those will go very quickly. You can also put those in the calculator. Please don't forget parentheses when you do that. Okay, and last, find the roots of the following quadratic. Now, if something factors, the roots are the x-intercepts. So if it factors, we just set both the factors equal to 0. If it does not factor, we use the quadratic formula. So you may want to glance at this one and think about the numbers that have a product of 7, the factors of 7. There are only 1 and 7, and there's no combination of 1 and 7 that can give me a 4. So I know that I'm going to go to the quadratic formula. So when we go to the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So for this problem, the a value is 1, right? A, b, c. So my b value is 4, so I have negative 4 plus or minus the square root of 4 squared minus 4 times 1 times negative 7. And I'm going to take that whole thing and divide it by 2 times 1. So if you have the quadratic formula in your calculator, you've got much less work to do than I do right here. Okay, this is a 16, and I'm going to be adding 28 to it and dividing through by a 2. So I'm going to keep going. I've got negative 4 plus or minus the square root of, this is going to be 44. All right, so I'm going to have 44 right here, divided by 2. That's the same as negative 2 plus or minus 2 square roots of 11. I took my perfect square of 4, moved it outside as a 2, and was left with an 11 inside. Do it on your calculator. You can get a calculator approximation for that by taking, out on your main screen, take negative 2 plus 2 root 11, and do the same thing with subtraction. Those will be our 2 answers. The other thing you can do, of course, is you can run the quadratic formula program on your calculator. It should yield this.